Okay, so we are now on part 2 of completing the square introduction. So we're just going to recap real quickly how to create a perfect square trinomial. We know that the definition of a perfect square trinomial requires that the first and last terms be perfect squares when written in standard form, and that the middle term is the product doubled of the square roots of the first and the last. Fancy talk for you take the square root of the first and the last, multiply them together, multiply by 2. So if we keep that in mind, looking at the two problems I have up here, the one on the left, this 10 was essentially formed by doubling something. I had to double 5x, right? That's what created 10. Now 5x needed to be created by the square roots of the first and last term, right? Well, I know what the square root of x squared is. It's x. I don't know what this term up here is, so I can't figure out the square root, but if x and something create 5x, obviously this has to be a 5, right? Well, then I look back up here. What can I take the square root of and get a 5? 25, okay? So I have just created a perfect squared trinomial. Okay, on the right side, same thing, right? This 12 is created by doubling something. 12 is created by doubling 6x. 6x is the combination of two square roots. Well, the square root of 4x squared is 2x, okay? Square root of this we don't know, but we can figure it out by working backwards. 6x is the product of 2x times something else. Well, 2x times 3. Well, what can I take the square root of to get 3? 9. Okay? Now, those are both pretty straightforward because I made sure I dealt with easy numbers. You could have something a little bit crazier, like maybe x squared minus 3x plus something, right? Well, this, if I undo the doubling, I've got 1.5x. Well, that's the combination of this x and this 1.5, right? Well, square root of what is 1.5? That's hard for us to figure out. So the way you go backwards, the opposite of square rooting, is to square it. 1.5 squared is 2.25. So sometimes you have to get a little bit creative with your decimals. They're not all going to work out pretty, but you can always, reverse the problem, reverse the process to figure out what numbers should be where.